Example 6 is probably one of the most difficult quadratic inequalities that you'll come across in Math 171. First of all, there's quite a bit of algebra to do up front. You'll need to square the binomial using FOIL or the box method. Get everything on one side so that one side of the inequality is 0. And then combine like terms to get this quadratic in standard form. This quadratic also ends up being unfactorable, which means the solution is irrational. It is real, but it's irrational. So we'll cover a lot of things in this example. So let's start off by doing the algebra that's involved. So first we need to square 2x minus 5. So I'm just going to do that separately. So if we use the box method, then we have 2x minus 5 going down, 2x minus 5 going across, and this box would be 2x times 2x, which would be 4x squared. 2x times negative 5 is negative 10x. 2x times negative 5 is another negative 10x, and then negative 5 times negative 5 is positive 25. So that's going to give us, if we combine our like terms, 4x squared minus 20x plus 25. Now, I want to take advantage of this and give you a little side note, a quick way you can square a binomial if you see the pattern. The quick way to do it is you take the first term and square it. That's what gives you 4x squared. You do the last term and square it. That's what gives you 25. But then you need to get the middle term. So 2x times negative 5 is negative 10x, but you have 2 of those, so you double that and get negative 20x. Just a little quick way to do that. So now we have 4x squared minus 20x plus 25 minus 1. So if we continue on with this, minus 1 is greater than 1. So we need to combine like terms. 4x squared minus 20x plus 24, because 25 minus 1 is 24, is greater than 1. And then if I subtract 1 from both sides to get 0 on one side, my cleaned up version is going to be 4x squared minus 20x plus 23 is greater than 0. So now I'm ready to find the boundary numbers. So remember, to find the boundary numbers, what you're going to do is solve the related equation. 4x squared minus 20x plus 23 equals 0. And I'm going to go ahead and tell you, to save time in this video, that this one is not factorable. So we're going to use the quadratic formula. So a is equal to 4, b is equal to negative 20, and c is equal to 23. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to give us negative 20, because it's negative b and b is negative 20, plus or minus the square root of negative 20 squared, and that's what I was talking about in the previous video. You really need to put this in parentheses, because if you're entering it in the calculator and you don't put it in parentheses, it will give you a negative number when it should be positive, right? A negative times a negative would be positive. Moving on, minus 4 times a, which in this case is 4, times c, which is 23, all over 2 times a, which is 4. Whittling away at this, you get x is equal to 20 plus or minus the square root of 400 minus, and 4 times 4 is 16, and 16 times 23 is 368, and that's all over 8. So this is going to give me 20 plus or minus the square root of 32 all over 8. And now I need to work on simplifying this a little bit. So if I go over to the side, the square root of 32, well, I can write that as 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So now I'm going to make radicals with the pairs. So the square root of 2 times 2 for that pair, times the square root of 2 times 2 for that pair, times the square root of 2. And I don't have another 2 to pair that with. So this would be the square root of 4, which is 2, times the square root of 4, which is another 2, times the square root of 2, which becomes 4 times the square root of 2. Let me pause for just a minute here too. As you do this factor tree, you might start to see another pattern. If I stop right here, notice that 16 is a perfect square. So we could have, once you find a perfect square, you could have stopped here and said the square root of 16 times the square root of 2, if I had stopped right here. And the square root of 16 is 4. And so that would have given us that same 4 times the square root of 2. All right, continuing on, that's going to give me, sorry, I'm running out of room here. I'm going to put this right here. 20 plus or minus 4 times the square root of 2 all over 8. And if I look in those 3 places, is there a number that will go into 4 and 8 and 20? And the answer is yes. 4 will go into all of those. So that's going to give me 5 plus or minus 1 times the square root of 2, which we normally don't write the 1 out there, all over, and 8 divided by 4 is 2. So these are your 2 x-intercepts. Notice that they are real, they're not imaginary. And to get to know where to plot these on the graph or on a number line, we need to get the decimal values. So get your calculator out. Type in 5 plus the square root of 2, hit enter, and then divide by 2, and you should get 3.2. Sorry. And if you type in 5 minus the square root of 2, hit enter, and then divide by 2, you should get 1.8. All right, so we can either use, I'm all into example 7's space here. We can either use the graphing method or the algebraic method. Since I've done both for a lot of examples, I'm just going to use the graphing method for this one. So I'm going to draw my coordinate plane. Remember, it can be a rough sketch. The 2 x-intercepts are 1.8 and 3.2. I need to find out if it's opening up or down. Since A is positive here, A is equal to 4, which is positive, which means the parabola opens up. So if I make my rough sketch, the parabola is going to do something like this. Remember, it's not important for this exercise to figure out exactly where the vertex is. We just need the intercepts and to know whether it opens up or down. So now to determine the solution, we need to go back to our inequality. And we were looking for where it is greater than 0. Well, that would be above the x-axis. So the parabola is above the x-axis here and here. So rather than being in the middle, that would be the solution if the inequality was less than 0. It's going to be this interval and this interval. And Alex I think is going to want you to give the exact boundary numbers. So we're going to use this in our interval notation. So the solution is going to be from negative infinity up to 1.8, which is the approximate decimal approximation for 5 minus the square root of 2 over 2. And we're going to unite that with 3.2, which was the decimal approximation for when we typed in 5 plus the square root of 2 over 2. And that goes to infinity. Now, the last thing to decide is, do I need parentheses or brackets here? So I go back to my inequality one more time. There is no equals to, and these values are where it was equal. So since we don't care where it was equal, we only want to know where it was greater than, we don't include those, and we notate that by putting in parentheses instead of brackets. So this is the solution to the inequality. Now, if I wanted to do the algebraic method, I would have just picked one number to the left of 1.8, which you could use 0. Remember, you don't have to use a decimal number just because your boundary number is a decimal. A number between 1.8 and 3.2, I could use 2, I could use 3. And then a number greater than 3.2, so I could use 4. And in that case, you would want to know which of those numbers is going to give you a positive answer because it's greater than 0. You should get the same thing even though you're using a different method.